This is a quick start guide second video tutorial for river basin simulation model rebasin. In the previous video tutorial, we have carried out all steps to set up the base case. Now we will prepare an alternative case called scenario A, in which the potential irrigation area is evaluated. To start the rebasin program, double-click on the start icon for rebasin. And since we will be working on an existing model, you use the open and simulate icon from the icon gallery. Click here and open the model we have built and click OK. This is the initial case management tool. And to start building the case, go to the case menu, open as new. We will be using the base case to continue from there. And we give it a name, scenario A. Click OK. We keep scenarios, measures, and strategies the same as the base case, and we change the simulation period. To do so, double-click on Specify Simulation Control Data task box. And we change here from 90, the starting of the simulation period is 1971, and it's still 1980, 10 years of simulation period. You keep the rest the same and click OK. To start editing the schematization, we have to double-click here on Edit Network and Database on Map, and click on Edit Network and Object Data. So we will start. We will adapt the base case schematization, and to start editing and adding the new nodes, you have to first activate the network, the Edit Network button. And first you can select the type of nodes you wanted to include, and then you select the type of operation you want to perform. So first we choose fixed irrigation node type, click add node, click one time. The second type of node we will be adding here is diversion node. We will use split connection. The difference between add and split connection is now we are splitting the river. To add the diversion node, we will be diverting water from the river to the fixed irrigation. So this will be a split connection, and you click one time in a position where you want to put the diversion node. After you add the nodes for fixed irrigation and diversion, and now we also chose a connection type, and then you will connect these nodes. For canals, or for the diversion canals other than the rivers, we use diverted flow. This will be used for canals. We select diverted flow and we add connection nodes. So we select a point from the diversion node until to the irrigation area. From the irrigation to the confluence, we select here stream flow, and we have this connection node. We start from the fixed irrigation and we drag it to the confluence. You can always adjust the position by selecting move, or the nodes you can be adjusted like this. The important note here is confluence can have more than one upstream link, but it cannot have more than one downstream link. Now we can rename the nodes that we just added. So you click here rename and select on. You can use left mouse to click on, and we can put the name. For fixed irrigation, put FIR, fixed irrigation 1. And for the diverted, also we click and we give the name. Click like this. We can also give a name for the main river, main 1, main 2, and main 3. We click here on the main one. It's already main 1, so click here on this. We give it a name, main 2, and we can give this one name 3 since we have already named main to downstream. That can be main 1, main 2, main 3. After you finish editing the schematization, we have to always save the network. Go to File and Save Network. And we can exit then. Go to File and Exit. And click OK. So at this point, the model database is filled with default data. So to add or to update the data we have, double click here, Edit Network and Database on Map, and go to Edit Network and Object Data. So activate the property data editor for fixed education using left mouse click and right click. Go to the data river basin simulation model. So for the fixed irrigation, we will be adding the physical data, which is the irrigation area and net demand. Double click here. The area is 10,000 hectares. You can always use this to drag and drop it down for every month. For the net demand, you can manually fill it out, but you can also make an Excel file to create the time series data and you can copy paste it. For this, we can just select this data, copy, and we paste it. Then finally click OK and apply. OK. For the diverted flow link, you can see activate and then see the data. We can keep the default value for now and click OK. After you finish entering the data, you can leave the tool, like go to File and Exit. Generate overview of the database. And we can go and see the overview of this database. Click on Report Tables of Database. We can go to Table 3.11 to see the fixed irrigation node data. You can see here it's entered. And you can also make sure that you don't have any errors. Press F7 and type error. And click Find. You don't have error. Even to make sure you see it down here, no errors detected. Then you click here, File menu, Exit, and click OK, and OK. Once the model data is ready, you can always run it. So double click here, River Basin Simulation, to execute and simulate the model. Also make the pre-processing. Now the result is ready. To see the result, double click here, Analysis of Basin Simulation Results task box. You go to Results on Map. And you can see the result with time step. You can see the link flow, and you can scroll here to see the change in time. You can also select two links to compare with, to see the results between two links. You can make a graph like this. You can leave the graph window, File, Exit. To see the other results, we can leave this one, File, Exit, and you can click on the results on chart. And we can see here fixed irrigation node, view export. You can see different types of results, that we can go to shortage and click on the fixed irrigation and select all graph. You can see the shortage of the water over time for this fixed irrigation area. After you see the result, you can close it, file, and exit. And you can also see the flow in the diverted flow link. View, diverted flow, links, all. And you can see the graph. Also the time change, the change of this flow over time. You can see it. And you can click here and exit. Click here, exit. Also, you can see the result in reports format and click here. Summary of the result. Let's see that. View. Go to the water allocation and in this table you will see the success time steps. The total time step for this simulation is 120 for the 10 years, and we see here it was 102, which means 18 time steps there was shortage in the system. You can review to see more information on the result from the summary, and you can also see the results from the other results format, from the charts and from the map. You can leave the file, exit, and you can exit from here as well and click OK. After you finish analyzing and also simulating, you have to always save the case and go to case and menu, click save. You can also exit from this menu, exit. And after you finish, you can close also this window, exit. And this is the second video tutorial. The next video tutorial will be on water quality with scenario A. I hope this video was very helpful. Thank you.